Hello, this will be part number 3, which provides a status on how I'm doing about the repair and reconditioning of this 10S 5P battery pack. Again, many thanks to some members on the EV blog forum who gave me a lot of suggestions. There are different approaches. Regarding the soldering and removing the battery cells and then putting new ones, this has been now solved and everything. So today I will address finally one how I have solved the balancing challenge. So as a reminder, all the cells here, they were made, these are Panasonic cells, they were made in 2016. The battery pack run more than 8 years for 19,000 kilometers. I estimate there was about 400 cycles of charging, discharging. So all the cells are not so new, but they still okay. So the real challenge is I noticed the bar number 4 was having a problem. When I removed the 5 cells, I noticed 3 cells, they were still okay, but 2 cells, they were just dead, totally dead. So this would create a lot of stress here. And then the BMS, and the BMS is somewhere here, it will declare, it will prevent, it will shut down the battery way too early, around 36 volts, you know. And then when I did all the reconditioning, repair, and cleaning, because the initial manufacturer in France didn't make such a good job, then I noticed there was one cell, so on the bar number 9 was leaking, and another one had a bump. So to make it short, I replaced 5 cells here and 5 cells here. So since we know that it's a real difficulty to balance match the ESR, the maximum charge and everything. So normally it's kind of a program obsolescence. If you have 1 or 2 cells dead, you know, it will be very difficult to find it. You're going to pay a lot of money to change just 1 cell, but then it would have another healthy factor. It will take more time to charge, and then everything will be out of balance and everything. So in my case, it was even a quite complex topic, because I've changed 20% of all the cells. You've got 50 cells here, change 5 here, 5 here. So at the beginning, I was scratching my mind, because when I would fully charge the pack, well, all the old cells in the old bars, they will reach around 4 volts. 4 volts, 4.1, 4 volts. And then the new one, they would stay only 3.75 volts. They would never charge. And they're coming from a lot, which I purchased. I didn't want to buy new ones, you know, because it would be even worse, the problem, you know, if you put very new cells here with old cells, it creates a mess. It's very complex, you know. So I bought cells made in 2020. So, you know, they're a bit younger, and they were claimed to not have been discharged. So my idea was, okay, I replaced 20% of the cells by 2020 cells. They are not new, but they are better. And how they can live with all the other, because remember, the BMS keeps the balancing and everything, and then when you charge, this one can store more energy, but then the BMS, depending on the firmware, the quality of the BMS, in my case it's not a sophisticated one, it will declare, oh, the charging is done, finished, you know, but then you don't have so much, you know. So there's been many ways to address that, and the best solution I found has been to buy that thing, which is an active balancer, you know, and you will notice, so it's I solder in parallel wires going to here, so same thing here, you know, and it took me a while, you know. So in a way, you have to imagine this circuit is a balancer, which is a hybrid mode with the very slow balancer in the BMS here, because I've noticed this one, it would take 20 hours, maybe 100 hours, 200 hours, because maximum it's 50 milliamps when it tries to rebalance. So now both work together. So here you don't see anything light, but when I was doing the charging, it's like an active and fast balancer, which complements what it does. And I'm quite happy now with the result, because we will see what it does, but I think it's the cheapest method to do. Another method which was suggested by one member would be to top charge, which means to charge maximum the more recent cells, So I could have done it, but I've decided to not do it, because I think at some point it would create, this one would have more voltage and then the balancer. So remember, it's a catch-22 situation, or chicken egg situation, where whether the pack is connected to an e-bike or not, I mean, the BMS is always connected, and he's always trying to, let's say, protect, balance, and then charge, discharge, and then say, okay, that bank is better, and so on. The BMS, clearly the BMS here, it's not a digital BMS. I think it's not a very good one. So it's like a turbo charge or turbo balancing. So this one can discharge much faster. And then when everything is stable, there's no LED lighting, because, so that's the solution. So I will install on the e-bike, we will run and we'll see what it does. So as a synthesis, the idea with this approach is to not change all the cells, because then there are so many strategies about depending the aging, because you see, you're going to spend a lot of time testing each cell, and then, so then it's like another industry. It's about the reconditioning or repairing industry. You're going to take many cells and then you're going to match them, because it's all about matching. But it can cost a lot of time. You need very specific equipment. So it's like if you would be a company, this is doable. So that's my the conclusion of, let's say, what I think is the best, cheapest solution to repair a battery pack when you have to change. In my case, 20% of the cells have been changed. 5, 10, among 50. Thank you. Bye-bye.